Hello and welcome to the Space Policy Edition of Planetary Radio. I'm Casey Dreier, the Chief of Space Policy here at the Planetary Society, bringing you another episode of the monthly show that explores the processes and policies that enable space exploration. This month, I'm delighted to welcome Maxwell Zhu, who is a graduate student at the Yale Jackson School of Global Affairs, recently completed an internship at the United States Senate working on the Committee for Commerce, Science, and Transportation, but most importantly and most saliently, was a co-author with me and worked with me on a project this summer to look at the development of China's space science program. The op-ed that we wrote, which was published in Payload Space newsletter that will be linked to in this show notes, was called Space Science is Part of the Space Race with China. And we did two things. We built out the upcoming future of China's space science program, demonstrating arguably a surprising increase in capability, maturity, and ambition from China's space science's initiatives, and contrasted it against the fiscal year 2026 budget proposal for NASA, which proposed a significant 47% reduction in NASA's space science activities. And you compare the two and you see a surprising, almost one-to-one comparison where NASA is canceling projects or giving up development of future ambitions. China seems to be building out those very capabilities. This is interesting for an administration and for a large majority of the US Congress that frames the current situation of geopolitical situation between the United States and China as a space race. This was actually in the title of a recent Senate hearing chaired by Ted Cruz in the Senate just a few months ago. So if the United States is in a space race with China, why are we pulling back from an area where the United States has a clear advantage and history and capability, namely space science? That's missions to the planets, space telescopes, Earth observation, monitoring the sun, the whole gamut. You cannot declare a race to be happening and then just ignore certain parts of space. The universe is larger than the moon and Mars. And if our political leaders want to declare and to win this space race they declare us to be in, you cannot just ignore the role of space science. That was our argument. Now, as you will hear in this conversation, Maxwell points out China's perception of its role and in its ambitions and planning are very different. And I think that's worth exploring as well. But if nothing else, the growing capability of China represents an exciting and truly ambitious set of science missions that are coming down the pipeline. And putting this all together into a coherent story and narrative was also really valuable. And this type of work that we do here at the Planetary Society, that we work with smart volunteers and future leaders in space policy, this is the type of thing that our members and our donors enable, and the types of things that we do that really no one else does. And we talk about that a little bit too. This analysis was novel. There was no one else really thinking about this. And if you support space science and space exploration and scientifically motivated exploration, searching for these big breakthroughs in exploration science, the Planetary Society is working to enable this at all levels. If you are not a member of the Planetary Society, please consider joining us at planetary.org/join. We put out programs like this, Planetary Radio, great articles, incredible depth of data sets and analysis. We are really driving space policy this year. These are the types of things we get to do as an independent organization. We depend on individuals. We are not funded by large aerospace corporations, and we're certainly not funded by government right now, and never have been. This enables us to pursue and to focus on what we care about and our shared values in space exploration, this curiosity-driven science. So planetary.org/join or planetary.org/donate if you just want to enable our activities. We cannot survive without our membership. If you are a member, thank you so much. You enable this show and others to exist. We, again, could not do this without you. And now, moving into our conversation with me and Maxwell Zhu. Maxwell Zhu, thanks for joining me today.
Thanks, Casey. Wonderful to be here.
So, Maxwell, this whole project kind of was an interesting, almost happenstance. you and I kind of did this together, but honestly, you did the vast majority of the work to validate this on China's space science growth. Can you tell me how you came to this in terms of space policy in particular, and what pulled you into this project beyond me recommending that we do this together? What interested you about this?
I think this has been a topic that's been on a lot of people's minds in the DC world for a while, which is this idea that in order to make the argument that space science is worth it, those of us who are really interested in the science side, we know what the value of science is. We've been making this argument for a long time. But in order to get that kind of consensus, you need to move things, especially on the Hill, recognizing that some of the other priorities on the Hill, that we need to beat China, we need to win the geopolitical competition, and figuring out how to fold those two worlds together has been a little bit tricky. This direct study, right, kind of came out of us wanting to have some hard facts and data that go beyond just saying China is probably doing something that is closing the gap on space science, right? That probably most of us would guess is true, but no one could really point to any missions or plans or funding or anything that could say, here's exactly how they're doing it, and here's exactly what we as the US need to do to make sure that they don't close that gap, that we maintain our lead. And so, as you know, Casey, we were talking about this while I was working on the Hill this summer, and all of us just kind of, after a lot of discussions, realized it'd be really good if we just sat down and just looked at the numbers, crunched the data, and then, a few weeks later, it turns out it was actually something that was really useful.
It started for me on top of that with this idea that we're looking at this 2026 NASA budget request from the White House that, raptures out a third of NASA's projects. And Andrew Jones, whom a lot of listeners may know, writes for Space News and other outlets, has covered a lot of China's space activities and their space science. And I just started to think about some of these things that China seems to be doing, Mars sample return, maybe this mission out to Jupiter, seem to be kind of pairing with the things that the U.S. is saying it won't do. And that's where, this kind of germ of an idea started. And this is why I'm so glad you gave some of your time to us to work on this, which is actually tying it to that was relatively, well, at least not, I don't know if you can tell me if it was challenging, but not straightforward. What was it like? Where do you find this information, trying to assemble what is the kind of Chinese space science program of record? And what did you learn about the China National Space Administration in terms of how they approach space science?
One of the biggest takeaways that I had was that China is becoming very, very serious about this in a way that they haven't been in the last, even 5-10 years ago, right? And the way you can tell is that China, which is traditionally very closed off about releasing documents to the public and plans and strategies, has begun releasing them in earnest. Right. So one of the things that we discovered was in 2024, they released their first ever medium to long term development plan. And then they released their version of their science decadal. This is for them a really big step. They're still not quite at the level of depth and sophistication and complexity that we typically see from, the ones that NASA releases, that the national academies that we release. But the fact that they're putting all of this out there really kind of shook me of just, wow, they're very serious. They're committed. They're not going to say something like this and then just forget about it next year. This is their plan to 2050. They're telling the world that they're going to race to close the gap with us over the next 2 decades. And I don't think they purposely did this because they saw us and the PBR coming down the pipeline that we were going to axe these missions. This does feel like a much more self-inflicted wound. Mm-hmm. But it does happen to line up so coincidentally that I almost for a second I was like, is there something? Did China plan this? Are they doing this just to match us exactly one for one? I don't think so after looking at the data and the timelines, but it is a heck of a coincidence. I'll tell you that.
Yeah. And I'll post on the show notes the graphic I put together from your research that kind of does this 1-to-1 comparison of where NASA is proposing to cancel and where China is proposing to put in investments. And it is a striking comparison. It's almost like the negative space, so to speak, of this plan. Maybe we should just highlight a few of what we're talking about here. I mean, I don't want to put you on the spot. Do you have a list in front of you?
No, I'm happy to talk specific missions.
Yeah.
Especially because I think part of the reason that it seems like such a coincidence, it's not because that China's necessarily trying to copy the US, but more that both of us recognize these are the big, high-profile landmark missions that you want to be doing if you want to be the leader, right? Both of us recognize it, and NASA has always been doing this, and now they're falling victim to the PBR and the budget cuts. And China is now realizing this, and now they have the resources, and they're stepping up, right? So some of the ones that come to mind, Mars sample return is obviously the most, a one that's probably biggest in the news, if only just because it's the one that's going to come up the soonest, right? So at the same time that we are canceling Mars sample return on our end, their Tianwen-3, which is planning to be launched in 2028, will, if everything goes right on their end, get to Mars, return the samples, be the first country to return samples to the Mars in what will be a huge coup, if only because up to now, no other country except perhaps the Soviet Union decades and decades ago has ever had a major space first that was not, the US or in conjunction with the US, right? It's always been America leads in space. And so if they pull that one off, that would be crazy. Some other big ones, right? They want to be the first country to return samples from the atmosphere of Venus. We are canceling 2 of our Venus flagship missions, Da Vinci and Veritas, that are currently in development. And then, of course, China has some longer term, I call them almost pipe dream missions. It's hard to take too seriously anything that's more than 10 years out, but they want to put a science station on Mars. They want to look for life on Neptune's moons, those 2 things we aren't even doing. Like, they're not even on NASA's long-term roadmap. So they're kind of not just taking what we're doing. They're actually, if everything goes right, going to be doing things that we aren't even thinking about right now.
Right. I think you emphasized here that there's this gradation or kind of levels of confidence that we're talking about here. I think that was when I was first looking at this before you started working on this problem, that was one of the challenges, right? Because we'd see these reports saying China's considering or proposing some, mission to Neptune or mission to Jupiter or Mars sample return. And without kind of a more detailed understanding of how the process works, it was hard to say which one is serious and which one is more speculative. What did you find about this process? You mentioned already this concept of like the equivalent of a decadal survey. And this is, I think most people know this, but again, this National Academy's process that every 10 years sets the priorities for U.S. space science, for each of NASA's major divisions. You said this isn't quite one-to-one, but it was similar in that there's an actual somewhat formal process now forming up through conjunction with the Chinese Academy of Sciences and their space program, right?
Yes, that's exactly it. And one of the things we saw in their decadal was that they've specifically authorized or announced, I should say, 5 missions. And when they announce missions, it's usually far less susceptible to internal political pressures that will cause it to, for example, have those funds rescinded, right? Their government does not shut down, as we record this, as, NASA and hundreds of thousands of other federal employees are furloughed and other funds are possibly impounded. That's not going to happen with China. That's not to say they don't have their own political pressures and all that. But when I see China expressly say, these are the 5 science missions that we're going to do by 2035, 100%, at worst, it means it might slip a year or 2 because of development delays, but I'm very convinced that they're going to do this, right? So on top of and this is in addition to the high profile missions that they've announced already, like the Tianwen planetary science explorations, right? Their Chang'e lunar exploration programs. On top of that, they've released another 5 in their decadal that's specifically focused on space science that will do things like long wave astronomy, exoplanet detection, gravitational waves, right? These are the things that we've been trying to do, that we've been trying to lead. And these are the things that I'm very confident that they're going to do because they don't usually, announce something and then backtrack on it. That's not their style.
Well, it's almost like the political back and forth happened behind the scenes before anything that doesn't get announced that you don't see, right? So by the time it gets to that point, it almost seems like that's been kind of worked out. And now this is the commitment and then it moves forward.
That's exactly right. Because I also think part of it reflects the difference in how they decide which science missions to fund. Here in the US, we're very bottom-up science-driven, right? Congress commissions the national academies to do decadal surveys. And then these decadal surveys drive what we as the community, both in the policy community and science community, consider to be the foremost science priorities. And it's almost gospel in a sense, right? If it's not in the decadal, it's not going to be funded most likely. But even if it is, Congress then decides whether or not we should fund it. That's all great. But they're essentially two independent entities with the decadals leading. Whereas in China, things are almost reversed, right? Which is that you get a lot more top-down direction, and the national academies work far more closely and are far more integrated into the decision-making process. And so you get less of just pure science driving which missions are being funded, and a lot more, this is already a considered attempt by all the relevant government decision makers, including their level of the White House, including their level of Congress, on what is our national strategy for space science, how this fits all these pieces. And so you're much less likely to have someone on the, 3 years down the line be like, oh, actually, this doesn't align for our priorities now. Like, it might align for science priorities, but we have other priorities, because they've already figured this out behind the scenes. And when they release it, they're speaking with a joint voice.
Is it too much on a limb to say this is that kind of Chinese model of state-involved priority setting is actually where we see the administration kind of moving with their priorities, then telling then science what to do, versus this ground-up scientific priorities then embraced by the administration's space science programs?
I think we're certainly moving closer to that direction than in the opposite direction. I don't know if I would quite go so far as to say that there's a shift.
It would be provocative here,
right?
But yeah,
no,
I think
but not just in the sense of, because I totally agree with what you're saying. But I think we've always been very state-driven, especially the national academies are congressionally chartered, right? I think we're just much more open and less committed to long-term planning the way our institutional structures are set up, right? Yeah. So we're much more open with, hey, this is what the scientists want. Now we're going to engage in a far more democratic deliberative process to decide, and therefore these priorities will change. Whether or not that's good for space is a different question from whether or not that's a good setup for society. I think certainly there are drawbacks for things like space mission planning, to be sure, even if probably on the whole, it's better for have an open and frank discussion. But certainly I don't think that's the reason we're falling behind in this race, right? Like, we got to the moon on that model. That model can work. It certainly can work. And in general, actually does, when you think about how, some of these, Hubble Space Telescope or James Webb, I mean, they were tumultuous, but they were multi-decade development projects, right? Yep. People made the case for them to succeed over time. And I do think there's an interesting dynamic between open democratic societies and inefficiency that people seem to get frustrated with, that are particularly notable in space. And then the solution being, I think you have, in a sense, commercial companies kind of occupy that more command control model, where, the efficiency of SpaceX comes from the fact that there's basically one decision maker, which, sure, you can be very efficient, but it's not democratic in that process, right? There's no expectations for democracy to be efficient. But I think going too far in the other direction, people then don't see those results. So there's there's a tension between these two things, particularly in space. And I think some people see that with China's kind of long-term space program to be an advantage, in the sense that because there's less democratic input, that there's more of a state influence in this larger geopolitical goals, that the consistency is there in a way you don't see on the U.S. side. And again, I'm not saying that's an advantage. There's democratic reasons not to do that. But it seems like maybe we're seeing a version of this express itself through the science side as well. I'd say that's a fair assessment. Though, interestingly, I'll say on the word efficiency, right? In this context, we're primarily discussing just the ability to plan in the long term and make decisions. But China, one of the things they haven't released is any funding data. They usually don't for most of their programs, right? And so it is extraordinarily difficult to determine how economically efficient are they being with their programs.
Right.
Does it cost them the same amount of money? I wouldn't be shocked if it cost them a little bit more than it takes our best scientists and engineers, especially for fixed price contracts. But, that's not to discount the fact that they have extraordinary science and engineering talent. It's just they are new to this game. For a lot of these things, they're doing it for the first time. It was certainly more expensive the first time we as a country tried to figure all this out. And so I think that's the part that they are able to hide because of the way the process works. And so if there is anything there that is, say, it is very possible. It turns out they're not very economically efficient at making these missions cost effective. But we just will never know that. Whereas in the US, it's very glaring because you'll have news reports and you'll have IG hearings and you'll have congressional hearings. And every time Artemis gets delayed, right, somebody somewhere is writing about it. And so I think that's another difference where the drawbacks of the Chinese model aren't always apparent because of how they control their information.
Certainly. And I know they're struggling to kind of kickstart a version of a commercial space industry for that same. You don't have that same kind of open dynamic society in that sense. And yeah, as you put, there's benefits and weaknesses to this. I want to go back to some of the science missions here because you highlight, I mean, just a few more from this list. You mentioned Chang'e, which is the lunar exploration programs. And that's definitely feeding. You almost kind of treat those a little separately, right? Because those are clearly aligned with human lunar exploration goals, it seems like, right? That they're testing technologies related to future human exploration. Tianwen is kind of their planetary exploration missions. And then you said these space science missions. But some of these space science missions, again, they're really branching out. And I think that's the big takeaway that I had from your research, in that it's not just these Moon and Mars focused priorities anymore. We're talking about, as you said, these space telescope that's going to be comparable to the Roman space telescope coming up. These gravitational wave observatories, free flying in space, that are similar to what Europe and the US, again, US canceled their portion of this, or want to cancel, of LISA missions to look for Earth-like planets. There's a lot of this very ambitious stuff really rolling in.
100%. Another mission is their Solar Polar Orbit Observatory, which is, it's supposed to conduct the first ever frontal imaging of the solar polar region. It's one of those, right, that if you're not a heliophysicist, just sounds like, oh, okay, cool, we're going to send another satellite to image the sun. Don't we already have tens or dozens of those? And sure, yeah, we do. But all of these represent things that have never been done before and are going to contribute valuable scientific information and demonstrate that China's here. China's a leader in the space science community. And if we aren't careful, then China's going to be the only leader, right? With all these missions, whether it's going to Venus, whether it's going to Mars, you're going to Neptune, you want to study gravitational waves. One of the things that I worry about as I looked at all these different missions is a lot of these are ones that international partners want to collaborate on, right? And are you going to collaborate with the country that has the plan out to 2050, that has the roadmap set and defined, is going to commit to these funding levels? Or are you going to partner with the country that, yeah, maybe they did some cool things back in the day, but are canceling projects left and right, are shutting down their government, are vocally saying that these missions aren't that important? Which one are you going to choose?
Well, and just abandoning projects that are already committed.
Exactly.
To, right? Yeah. Right. An unreliable partner.
And for a lot of these missions, the thing that I worry about the most is just perception. Because yes, it is bad. It is terrible that we have missions that will be closed and shut down even though they're still operating. Yes, that's absolutely not what should be happening. We're going to lose that data. And yes, it's true, we're going to pause a lot of amazing projects that should continue to be in development. But, with the first, a lot of these missions are aging. Their data is important, but not, I would say, the flagship missions, that is going to define NASA forever. Missions that are halted in development can still be restarted, even though there are long-term consequences. But leadership is as much about perception as it is about anything else. And that's not something you can get back, right? If everyone in the world starts thinking of China as a premier partner for space science, no amount of new funding 10 years later can make up that ground that we lose in the next 10 years, even if we suddenly doubled our NASA budget, right? Because they're going to ask, what if you just canceled them the next year again, right? And I think that's the true, we think 30 years out to the 2050 mark they have in these plans. And what we really need to do is make sure that other countries don't start suddenly seeing China as the premier destination, as the international hub for space science, because that's exactly their plan. That's what they've literally said in their long-term development plan, which is they want to be where everyone goes. And it's not hard to read between the lines of right now, the US is where everyone goes. In order for China to be there, they have to supplant us.
We'll be right back with the rest of our Space Policy edition of Planetary Radio after this short break.
For over 45 years, members of the Planetary Society have teamed up to crowdfund science and technology projects like LightSail, the 100 Earths Project, PlanetVac, and so many more. The STEP grant program continues that concept but uses an open call for proposals to cast our net far and wide to find the best projects. The first 2 rounds of STEP grant winners have done great stuff, ranging all the way from developing a new technique for studying near-Earth asteroids to doing a careful comparison of different ways to grow edible plants in space. We're once again going to invite the brightest minds worldwide to discover the next breakthroughs in our 3rd round of grants, and we need your help. This vital scientific research will be made possible with your support. Right now, funding cuts at NASA and the National Science Foundation are threatening scientific research. There's never been a more urgent time to support independent scientific funding. This is real space science and technology funded by you. Donations given today will go directly to the next round of STEP grant winners. Please join us in this crucial endeavor by making a gift today at planetary.org/step. Thank you.
What has the kind of overall perception been? I mean, maybe I'll step back and say, and so in the op-ed you and I wrote,
right.
I think we framed this as, with this data, that in this context of this new narrative, I'd say relatively new narrative of a space race, maybe just newly, the pretext is now the context. You know, it's right. You have congressional hearings openly saying this is a new space race with China. You have the acting NASA administrator saying we're not going to lose the space race. And our framing was, if you say you're in a space race, you can't just ignore certain parts of space and say that doesn't count, right?
Yep.
It's like, okay, the cosmos is a lot bigger than the moon and Mars, but here we are, at least as the proposal, kind of functionally just ending half of, a huge portion of what we do in space science around the solar system and space telescopes and Earth observation, but saying we're going to win a space race. Do you see this idea resonating at all? Or did you even just see this as this, people not even think about this, of space science counting versus human spaceflight in your experience so far?
So I actually start answering that question from the Chinese side, which is, if I had to guess, I don't think they see it as a space race, which is, I know, interesting considering what I just said, that in their plans, they are going to close the gap. They're going to race. But I think that is the inevitable conclusion when you read between the lines of what they're saying. And I think it is hard to see a world in which we're not racing against each other on these missions. But from a framing perspective, a mindset perspective, China has historically not really viewed how they compete with us as actually a competition at all. Mm-hmm. In fact, and the exact phrasing is lost on me, but I remember talking to some folks. I'm currently a graduate student at the Yale Jackson School of Global Affairs. And last year we had a delegation of Chinese students from Renmin University, essentially our counterparts, come and discuss, all aspects of U.S.-China competition, of science and technology trade. And one of the things that really struck me was, we called it U.S.-China competition. Their phrase for it translates much more closely to U.S. competition against China. In other words, they see it as, we're just doing our own thing. We really want to be really good at these things. We want to be a world leader. We don't quite understand why the U.S. keeps framing this as a race when all we're doing is trying to be the best, in some cases catching up to the U.S., which is the best. So I do think that insofar as it is a space race, and I certainly think it is from our perspective, it's not one that's shared across the Pacific, which makes for very interesting discussions with our, Chinese counterparts on these issues, because it means that when we're trying to solve issues, whether in space science or elsewhere, they don't quite see it as, it's a you win, we lose, we win, you lose, first to plant the flag. That's something that has always stuck with me, because on the U.S. side, to answer the U.S. side of the question, right? Like, absolutely. I think we are in a space race. It's hard to see how we're not. It's hard to see how their version of their 2050 plan doesn't put them in direct competition with us on a lot of these issues. Whether or not a space race is good is, I think, a separate question. But the fact is that everything we're doing, whether in science, whether in space exploration, whether in national security space, commercial space, you name it, our main competitor is China. They're trying to capture the market, or have landmark missions, or achieve geopolitical first, or have zones of control. Whether or not they admit that this is what they are doing, it is the inevitable intent. And so here we are, we're in a space race.
Mm-hmm. I think that's really important context. it's kind of a one-sided framing.
Yeah.
that's worth emphasizing. And I mean, I've always been personally ambivalent about the framing as well. And it's certainly tempting. And I think there's like there can easily be a short-term technical or like a infusion of energy and money if you can get that buy-in for it. But I think, looking at the longer history, races have an end. And so if you win the race, then, as kind of the classic example of Apollo, it's like, well, okay, well, then we won. What do we need to do this again? The China perspective is like, we're just trying to build to be the best. And if you want to call it a race, fine. Yeah. But it actually takes a lot of the pressure. Then they're not, in a sense, reactive. And I feel like that's the other potential downside with the pure framing of this as a race, that we have to be reactive to what they're doing, that they set, but through their action, through China's actions or whatever, it sets U.S. space policy. And I think that's where, again, the decadal process is so valuable. And I think even just framing it as like the one-to-one where NASA's cutting, China's investing in, doesn't mean we do it because they're doing it. It's because these are clearly valuable scientific goals, right? No, I mean, that's what I think the essence is, right? That you have particularly on the science side, you have a convergence of similar goals. If you all have it, I mean, it actually validates science as a concept that you have, it's presenting some objective reality among two very different cultures, right? That there's, gravitational waves, a search for life, solar physics, these things are really important to understand. So we have mutual, we have joint areas of interest in this.
And I think on the pure science front, we are quote unquote winning, right? Because I agree with you that on the pure science front, calling a race does seem counterproductive to the very goals of science, and calling it winning does seem to go against the way that we should think about science, which is for the benefit of all humankind. But one of the things that is interesting about China's strategy is that even if they achieve everything they want by 2050, and even if we implemented all of the budget cuts we did today to NASA, we would still have more missions than China by 2050 in space science, right? Like sheer number of missions. And part of the reason is China is focusing so much on these high profile missions. If you look at all the missions that they've expressly authorized, they have, I'll say 6 or 7, I think that I would say are high prestige ones. So your Chang'e 7 and 8, you have your Tianwen 3 and 4 that go to Mars and Jupiter. They have an asteroid redirection mission, their version of the Roman telescope, and then SMILE, which is one of theirs to study the solar wind and Earth's magnetosphere. Okay, so that's like 7. Then you add the 5 that are in their decadal. I won't go over all of them. We've talked about them many already. And then they have 3 that are more ambitious missions on their long-term roadmap: Venus sample return, a Mars science station, a Neptune mission. Great. Some of these are scheduled for 2039, so it's anyone's guess whether they'll get launched, right? But that's not even 20 missions. That is like their full, here are the ones we've absolutely committed to. And what's lacking from a lot of these, right, are the small scale, really scientifically valuable missions that are never going to make a White House press release. So I think of, for example, the Terra, Aqua, and Aura satellites, right, that are slated to be canceled in this year's PBR. Terra does land surfaces, Aqua does water systems, Aura does atmospheric gases. They were launched decades ago. Everybody from climate modelers to DoD missile defense uses their extraordinarily valuable and continuous data and has used it for decades. They cost about $30 million, right, which is a tiny fraction of NASA
per year, to continue operating them.
And NASA every year has, like, for reference, a $2.1 billion science budget, at least under the 25 budget.
Earth science,
And those are not the kind of missions that China is announcing, right? These ones that are like going to be really, really helpful for the scientific community and for our knowledge, but aren't going to make any headlines. And so if in terms of the sheer amount of science we're doing, I don't want to make it seem like China is about to overtake us on everything. Everything I've said today has, in this op-ed and that we've talked about and that we've looked at is still true, that it would be enormously detrimental to our national interest and to science for us to pull back as China is surging forward. But they are surging forward specifically on very key high-profile missions, and they don't seem to be trying to be like the only provider of all the best scientific data. Because right now, NASA still has dozens of missions in the air. They still will, even if the worst comes to pass and this PBR is implemented. And a lot of these, China's not trying to replicate. They're not trying to replicate the unsexy missions, the workhorses. They're trying to replicate the ones that are like, oh my God, look what China's doing. Everybody go pay attention to them. So I think from the pure science front, that is something that I still feel if not comfortable, at least not as worried that this is where we'll lose our edge, you know?
Well, I think that's where the degree and duration of this, I'd say, scientific crisis comes into play, right? Because whereas the 3 missions you just mentioned, they're all launched in the late 90s or early 2000s. And there's a lot of projects NASA has that it has right now over 100 projects in space sciences, with most of those being inherited from decades of investment. I mean, even, Voyager launched in 1977.
Yeah.
But I mean, those all tail off over the years, right? And I think what's the real challenge now, as you point out, beyond just I'd say the inherent tragedy of cutting off missions that are providing good science for no reason, but it's the pipeline. And, one of the plots that I put together for our op-ed was looking at, based on your missions you found, looking at the number of missions, space science missions China's doing by decade. In the 2000s, they did 3. 2010s, they did 13. And then 2020s, with the likely ones have already launched, plus the likely ones you identified, they're looking at like 22. So they're more than, it's kind of doubling from the last year. So there's a huge amount of growth. And that's going to be the interesting, like, is their pipeline accelerating? And is our pipeline diminishing, right, at the moment? And I think that's where you start to see a decade down the line, a very different balance in terms of this degree. And I think you're right, that this prioritization of I call them big swing missions, right? Something like Mars sample return, that are high risk, potentially, very dramatically high reward. Same with some other missions for astrobiology, or gravitational waves. They're going for these very notable going into the record book stuff. But and then what I call meat and potato science, which is not a
that's a good term, meat and potato science. I'm going to use that one, Casey.
It's just like your hardy stuff, and there's nothing fancy about it, but it keeps your data pipelines full. That kind of stuff is less common. But I wonder if you'll see an increase of that over time as China's space science matures. Because again, I think what's so interesting to me, again, that what came out of this was how few people seem to realize this, like from the work that you did. You and I have both been contacted by all sorts of folks asking about this op-ed and our data. And it's all stuff that you found publicly online, but was hard, it wasn't easy to put together. And I wonder if, we had someone ask us, who's the academic expert in this? And I don't think there is one just on space science, right?
Think so, no.
China's space tends to be dominated in terms of U.S. interest by national security and then human space flight. And the space science thing, I think, is this kind of dark horse here, because I wonder if, because it's changing so rapidly, right? Because it's happening so fast, that, the lifetime of a single PhD encompasses, roughly a third of all China's space science missions that they've launched. And so I wonder if this is a relatively new awareness coming into play, in terms of that this is something that, as you said, an accelerating program that is showing huge amounts of commitment, and then growing maturity of capability and ambition.
I think that's partially the answer. And I say partially because academia does generally tend to lag, especially on the science and tech issues. It's something that when I was working on the Hill this summer, I noticed the more cutting edge tech was, the lower proportion of academics that were likely going to be briefing Congress on these. And part of it is the way that especially tenured faculty are set up in institutions, right? Like I see this all the time here at Yale, which is we have very few science and tech faculty, and all the folks working on science and tech policy tend to be either fellows or people on short-term appointments or lecturers, because in order to become tenured faculty, which are the cornerstones of academic institutions, right, you have to have a body of work stretching at least a decade, if not longer. So it is almost by definition impossible to get tenure on China's space science if China's space science wasn't even a thing until 5 years ago, right? Because there's no way you could have built that body of work. And so it is extremely difficult for academia proper to keep up with that kind of thing at the rate that policy changes. So I think that that's one part of it. I think the other part of this puzzle is that there's usually been a disconnect between people who work on science and people who work on, quote, geopolitical or national security issues. So when I had the opportunity to talk with Bill when I was working on the Hill this summer, I had a bit of a cognitive dissonance moment when Bill and I, who had grown up watching talk about science and the importance of science, came in and we had a discussion around, here's the importance of U.S. soft power and how this fits into the larger dynamics of U.S.-China geopolitical competition, right? And here was this guy I had grown up watching with a bow tie and a smile on his face and cracking jokes, talk about these very national security geopolitical topics. And that's always kind of stuck in my mind because there's not a huge amount of overlap between people who are comfortable and have the expertise and the resources and the interest working on national security or geopolitics or US-China competition on the one hand, and then science on the other. And I don't think this is something that's unique to space science, right? One of the other projects that I'm actually currently working on here at Yale is the overlap between environment and national security. Specifically, I'm very curious, for example, are there NASA Earth science assets that could be used for Golden Dome? Right. And that requires bringing together a lot of very disparate worlds, because I've been trying to talk to people and reach out, and the number of people who know and are comfortable and interested in missile defense versus the number of people who are interested and comfortable in talking about Earth science assets for NASA. That Venn diagram is also very small, right? And we're seeing a lot more of these where we need people who can interact and talk at these intersections. But for topics like how the US and China compete in space science, how we might use Earth system assets for national security, it's not always obvious how to put all the pieces together in the room, even if, like, on the whole, Congress and the executive branch have all these pieces, right? And I think that kind of stops us from getting the full picture at times on these issues.
Where do you see this going? I don't know. You're still a graduate student, so you haven't yet like made a final commitment, but you have a number of interests. Did you see, based on then the response to this, that this is an idea that can take hold and this is something worth paying attention to more?
Are you talking about specifically China and space science, or the larger issue of...
Let's start with China and space science.
So definitely yes, when it comes to China space science. One of them is practical. It's just convincing folks who maybe science hasn't always been the greatest argument for why to spend US dollars, which is a fair argument, a reasonable discussion to have given everything else we can and should fund as a society. Putting this in the context of a larger, bigger framing of US-China competition will just be more politically palatable. It will help build consensus. And as much as I enjoy science and as much as I want us to do cool things in outer space, at the end of the day, we need to pass funding and legislation that allows us to do these things, right? So from a political perspective, absolutely. But I think I am seeing this broader and broader trend, especially amongst my generation, but certainly across the board, right, of just the distinction between pure science technology versus non-science and tech things, shall we say, right? You can group this by congressional committees if you want, right? Like the overlap between things that the science committee covers versus armed services and foreign relations covers. It's definitely getting blurrier, right? With things like AI, things like quantum, things like space, where yes, in the past has kind of been always true, but as the pace of science technology innovation increases, as the requirement for technical knowledge increases, as the world becomes a slightly crazier place than it definitely was maybe 5-10 years ago, all these distinctions are becoming more and more blurry. And it's increasingly vital that if we're going to make good decisions, you need people who are able to work at these margins, at these intersections, and bring people from these disparate fields and make, do the kind of research that we did. Because it's not like it's particularly, I don't think what we did on this research project was any harder than, say, a physics problem, right, or a pure policy problem. It was just a matter of putting the pieces from those two worlds together.
Mm-hmm. Right. It was all out there. It just you needed the specialty and the time, and I think the prioritization to even acknowledge it. And that's why it was, again, so fascinating just to see, again, that there's lots of low-hanging fruit out there. And also, just as you said, there's this time series issue of just, if things are happening fast, sometimes they don't bubble up into these compartmentalized approaches. But that's like a whole separate but interesting discussion about, is there more and more blur between all these previously relatively compartmentalized policy issues that are starting to run into some internal structural challenges. But we'll leave that for another podcast.
Yeah, and I think the last thing, right, I'll say on this is China gets to make moves too, right? Mm-hmm. This isn't their final version. They made all this before we put out our PBR and before our government, is shutting down. It wouldn't be the craziest thing in the world if they saw this and thought, hey, we have an opening. Let's press harder on the gas pedal. There's absolutely no reason for them to just sit by and watch as the world unfolds around them any more than there's any reason for us to do that. And so I wouldn't be shocked if we have further developments in this over the next 6 months, over the next year, or the next 5 years, because they are seeing the same thing as we are, and they're an independent actor. And if they're smart and they want to achieve their 2050 goals, they'll see this as an opportunity and act accordingly.
Very good point, Maxwell. Where can people follow you on this issue? You have a new Substack, I believe.
Yes, I do. My new Substack is called Galileo 5. Galileo 5, where 5 is spelled like the Roman numeral V. For those of you who are West Wing fans, it comes from the episode called Galileo 5, where President Bartlett goes on and waxes poetic about how awesome space exploration is with a mission called Galileo 5. You can also just go directly to the URL, which is maxwellzhu.substack.com. That's maxwellzhu.substack.com. I'm writing a lot more about anything related to civil space policy, especially if that's something that Congress could legislate on. So there's further information here around what China's space science strategy is. There's probably going to be stuff around whether there's any first mover advantage to Lagrange points that I'm working on with some NASA astrophysicists on the project I mentioned earlier, on whether NASA missions could be used for Golden Dome, things like that. Just, I am absolutely fascinated with kind of space science, space exploration, what the US government should be doing. So if you're interested, take a look.
I'm a subscriber, so I recommend
folks. You might have been one of the very first ones, so thank you very much.
Absolutely. We'll have this link on the show notes. Maxwell, thank you so much for coming on and talking about it. It was great working with you on this project, and I'm very excited to see more of the work that you're doing here in the coming months and years.
Thank you so much, Casey. Always a pleasure.
We've reached the end of this month's episode of the Space Policy Edition of Planetary Radio. But we will be back next month with more discussions on the politics and philosophies and ideas that power space science and exploration. Help others, in the meantime, learn more about space policy and the Planetary Society by leaving a review and rating this show on platforms like Apple Podcasts or Spotify or wherever you listen to this show. Your input and interactions really help us be discovered by other curious minds, and that will help them find their place in space through Planetary Radio. You can also send us, including me, your thoughts and questions at planetaryradio@planetary.org. Or if you're a Planetary Society member, and I hope you are, leave me a comment in the Planetary Radio space in our online member community. Mark Hilverda and Ray Paoletta are our associate producers of the show. Andrew Lucas is our audio editor. Me, Casey Dreier, and Merk Boyan, my colleague, composed and performed our Space Policy Edition theme. The Space Policy Edition is a production of the Planetary Society, an independent, nonprofit space outreach organization based in Pasadena, California. We are membership-based, and anybody, even you, can become a member. They start at just $4 a month. That's nothing these days. Find out more at planetary.org/join. Until next month, ad astra.